there's another totally different but complementary way to use inheritance known as implementation inheritance, and we're going to see that in the context of something known as a default method. So for better or worse, Java also allows what's called implementation inheritance, in contrast to what we saw before. Whenever we use implementation inheritance, we're going to inherit not just what the list should do, but also how. So instead of just getting a list of all the things that a list should be able to do, we're going to say how to do it. The way to do this is we're going to use the default keyword to specify a method that all subclasses will be able to use. So let's try this out. So let's do, in this case, the keyword we need is default. It's a new one. So I type default, and then I'm going to say public void print. And then here, rather than putting a semicolon, we are going to provide this to any list that implements list61b. So prints the list, works for any kind of list. Now, obviously, this method can't try and access instance variables because there are no instance variables here. Instead, we're going to use these methods to do it. So you might consider how you would do that, but I'm just going to spoil it pretty quickly. Up to you. So I'm going to start by saying int I equals 0. And then as long as I is less than size, I'm just going to print out the ith item, which I can get by doing get I. I'll add a space to make it look nice. And then I'll say I equals I plus 1. Okay, so simple enough. How do we actually use this method? Well, we can just go back to isAdemo. And here we have, okay, well, this is some list equals new slist. And because slist implements list61b, that print method will appear in the list. There it is, print, okay? Because that's part of what being a list is all about. Okay? So you implemented it for free. So in this case, if I run my code, I'll get back elk. If I actually want to see it do something interesting, we can do add last dwell on, I don't know, existential crises. I don't know. This is what elk do these days. I'm just guessing. I don't know. I don't know any elk. Okay, so if we run this code, hopefully it should print them out in order. Is it demo? And there we go. So it printed out just fine. Good job, list61b. So that's a default method. Now actually, I'm going to show you a slightly different way to write loops now. It's kind of divorced from the rest of the lecture, but it's something that I ran out of time to do in a previous lecture, so let's do it now. So I'm going to make an observation that often when you write a loop, there's this certain pattern. You have a line that initializes a variable. You have a check that determines if the loop should run. And then finally, you have some kind of iteration or increment, something that increases whatever my counter is. So there exists another construct in Java which looks something like this. It goes for initialization, so for init, check, iterate. Okay. So what does it mean to initialize? I'm going to say for int I equals 0. What's my check? I is less than size. And what's the thing I do at the end of the loop? I equals I plus 1. So this right here is the same thing as this code right here, but it's all on one line. Now, often I try and tell people not to be clever when they're programming, but this is something so common in languages that even though it's a little bit weird syntax, everybody will know it. If you don't know it yet, you're going to see it a lot. So may as well learn it right now. So at that point, I just move this inside of the loop, and when I run it, it'll work just fine. So try that out. Maybe you'd use the visualizer to see exactly what's going on later, but we can run it just to make sure we didn't break anything right now. Okay, good. So while loops, not as good as for loops for the most part. These are considered more, people use the term Pythonic, loops that feel like Python. This is more Javonic, I guess. I've never heard that term, but I made it up now. So what have we achieved? Well, our interface has not only a list of what a list can do, but also how you can print a list. I have one question for you then. Is this method efficient? So yeah, 4 possible answers. 1, it is inefficient for both A lists and S lists. 2, it's efficient for A lists only, S lists only, or finally the last is all of them. So think about that for a moment. And I'm being a little open-ended about what efficiency means. Okay, so how do we think about this? Well, I guess one way we can appeal to this, or figure out this question, is look at A list and see how get works. So get is going to be fast in A list because it immediately gets all the items. Whereas if we look at S list, what do we have to do again? Let's see, how did it work? I knew something about scanning. Get. Okay, actually, yeah, this is a lot of work. We've got to iterate through some big old list. Not so great. Okay, so in this case, it is efficient for A list, but inefficient for S list. and that's because get has to work its way all the way through the list. So the next video, we'll talk about how we can deal with this, but that's basically what we get out of this implementation inheritance idea, is the ability to not have to write a print method if we don't want to. There's no print method in slist, yet we can print them all the same.